All right, next question here. We're asked to find angle A, line segment AC, and line segment AB. So first of all, I'm just going to change line segment AC. Another way to write that is little b. And line segment AB, another way to write that is little c. So that will make it easier for me to think about this triangle in terms of Pythagoras. But first things first, let's solve for angle A. This is a right triangle, so we know that angle A plus our angle B add up to 90 degrees. And angle B is 50 degrees, so 50 plus our angle A are 90. So if we subtract 50 from both sides, we get angle A is 90 degrees minus 50 degrees, which gives us 40 degrees. Okay, line segment AC, I'm going to call B. And so let's see, how are we going to do that one? Well, if we think of this triangle with 50 degrees as our target angle, then this side over here is opposite and the 74 is our adjacent. So tan of 50 degrees is opposite over adjacent, which is B over 74. So we can multiply both sides by 74. And so we get B is 74 times tan of 50, and we can calculate that out. Let's go to the nearest tenth. So it would be 88.2. Okay, now I'm going to store in my calculator the longer version of that. I'm actually just going to leave it in my calculator right now the way it is, but you can also write down a bunch of decimal places. So you've got a pretty good approximation of that value. And then we're looking for line segment AB, which is the same as little c. And we can use Pythagoras for that because we know a squared plus b squared equals c squared. So 74 squared plus our result from up above squared equals c squared. So I've still got that value stored in my calculator. So I'm just going to square it and then add 74 squared to it. And I get 13,253.4348. And then we're going to square root both sides. And that gives us a C value of 115.1. Okay, next question. A road rises 6 meters vertically for every 50 meters of horizontal distance, and we want to know what angle the road is inclined. So we're looking for this angle X here. So relative to that angle X, the 6 is my opposite side, and the 50 is my adjacent. So I can use the tan ratio. So tan of angle X is opposite over adjacent, which is 6 over 50. You can write the meters in if you want. Note they'll cancel. And so we get 6 over 50.12. So in order to figure out just angle X then, we're going to take the tan inverse. And so I get angle X is 0.12, so tan inverse of 0.12 gives me, to one decimal place, I get 6.8 degrees, which is a reasonable number for a road grade percent. Okay. Next one. I like these ones. If you've got a tall tree around in your yard or the park somewhere and you want to find out how much, how tall it is, you can do this too using a tool called a clinometer, which measures the angle. So Joan is standing here 20 meters from the base of her tree, and her line of sight to the top of the tree makes an angle of 54 degrees. Okay, Joan is 1.6 meters tall. That's important because this is Joan, 1.6. And since we're measuring from Joan's eye level to the top of the tree, I'll find a brighter color. What we're really doing is measuring this distance here. Okay, so this is going to be, let's call it X. And then in order to figure out the tree height, we're going to have to add on that extra 1.6 meters here. Okay, so to figure out X, we know this is 54 degrees. X would be our opposite side, and we know that our adjacent side is 20 meters. So we're going to use the tan ratio. So tan of 54 degrees is opposite over adjacent, which is X over 20. And so we're going to multiply both sides by 20. And so X is 20 times the tan of 54. And that gives me 27.5. And we're in meters. So X is 27.5. So the tree height is going to be 27.5 meters plus the extra 1.6 meters of Joan's height. And that gives me 29.1. So the tree is 29.1 meters tall. And I just realized I should probably write a sentence for the last question too, since it was a road or a word problem. So the road is inclined 6.8 degrees. Okay, moving on to our last question for this section. We have this roof. For every 2 meters of run, it rises 1.2 meters. And we want to know the pitch of the roof. So we're looking for angle X here. Okay, so relative to angle X, this 1.2 is our opposite side, and 2 is our adjacent side. So tan of angle X is opposite over adjacent, which is 1.2 over 2. Okay, 1.2 over 2 gives me 0.6. And so if I want to solve for angle X, I'm going to take the tan inverse. So angle X then is the tan inverse of 0.6, which rounded, it doesn't tell us what to round to, so let's round to the nearest tenth. Nearest tenth, it's 30.96, so I would get 31.0 degrees. So the pitch is 31.0 degrees.